Okay, today we're going on a journey to one of the most hostile places on our entire planet, the very bottom of the ocean. Down there, there's this invisible force so incredibly powerful it can crumple solid steel like it's a piece of paper. So let's figure out what that's all about.
So let's just try to picture this place. We're talking about going down nearly 11,000 meters. That's almost 7 miles straight down. It's a world of absolute darkness. It's near freezing. But the one thing that defines everything down there, it's the pressure. Right at the very bottom, in the Mariana Trench, the force pushing down on every single square inch is 15,750 pounds. Now, that is such a massive number, it's almost impossible to wrap your head around on its own. To make that number feel real, just imagine holding your phone in your hand. Now picture stacking a few cars on top of it. That is the kind of force being applied to every single square inch of any object at that depth. It's just mind-boggling. So where in the world does this incredible force even come from? Well, it's not some kind of magic. It's just the simple, crushing weight of all the water sitting on top. Let's break down exactly how that pressure builds up. See, it all comes down to the weight of what's above you. Right now, you've got miles of air above you, but you barely feel it because air is so light. But water is about 800 times denser. And that extra density means the weight adds up incredibly fast as you descend. And check out how quickly it builds. At the surface, where we are, you're at 1 atmosphere of pressure. Go down just 10 meters. That's about the height of a 3-story building, and the pressure already doubles. By the time you get to 100 meters, it's 11 times what you're feeling right now. Now just imagine that all the way down to 11,000 meters. You're at over 1,100 times the surface pressure. Whoa. This really puts that destructive power into perspective. It's not some kind of gentle squeeze. The pressure is so immense, it would destroy pretty much any material we'd normally encounter. It is a force that can instantly, and I mean instantly, annihilate almost anything we think of as being strong. So this unimaginable force just raises a huge question, right? How could anything possibly survive down there? And this sets up this really fascinating contrast between two totally different survival strategies, our technology versus nature's own incredible adaptations. And this just lays out the two opposing philosophies perfectly. Human engineering, our approach, is all about building a fortress, right? Keep the pressure out at all costs. But biology came up with a much more elegant solution. Just let the pressure in and equalize everything. For submersibles, it's a brute force game. The solution? We build these thick, spherical hulls out of titanium, a sphere being the absolute perfect shape to distribute that pressure evenly. The windows have to be inches thick. Even the electronics are bathed in oil to balance out the forces. It is a constant, high-tech battle against the sheer power of the ocean. But deep sea life? It doesn't fight the pressure at all. It just incorporates it into its very being. These creatures have no air spaces like lungs or swim bladders that could be crushed. Their cell membranes are made of special fats that stay fluid and don't get stiff, and their proteins are built to resist being squeezed out of shape. It's just a masterclass in adapting to your environment instead of trying to resist it. For a lot of these deep-sea creatures, survival boils down to this one little molecule, TMAO. Think of it like a kind of molecular scaffolding. It literally props up their proteins, holding them in the right shape and stopping the pressure from squishing them. And here's the cool part. The deeper a creature lives, the more TMAO you'll find in its cells. But here's the thing. Even nature has its limits, and it seems like that limit is set at this depth, about 8,200 meters. So why that specific depth? This is where it gets really fascinating. To survive any deeper, a fish would need so much TMAO in its cells that the chemical itself would become toxic. It would completely mess up the fundamental process of osmosis. Basically, the chemical balance would get so out of whack that it would start pulling vital water out of its own cells. It's a hard chemical boundary that fish, it seems, just cannot cross. You see, the pressure in the abyss doesn't just make it hard to live, it fundamentally rewrites the rules of physics and chemistry. The deep ocean is, in so many ways, a physically different kind of world. On a chemical level, that immense pressure actually changes how water itself behaves. It becomes a better solvent, especially for gases like carbon dioxide. And this is hugely important for our planet because it allows the deep ocean to act as this massive storage tank for carbon, which helps regulate the global climate. And the physics are just as weird, if not weirder. The water becomes denser, and get this, sound actually travels faster through it. This completely changes the acoustic landscape down there, affecting everything from how animals like whales communicate across vast distances to how our own sonar equipment even works. So why does all this matter? Why should we care about understanding this extreme pressure on our own planet? Well, it turns out the lessons we're learning in the abyss have implications that reach way, way beyond the bottom of the Mariana Trench. And here's where it connects to something much, much bigger than our own planet. The deep ocean is our best real-world laboratory for astrobiology. When we ask, could life exist in the hidden oceans on moons like Europa or Enceladus, the answer starts right here. These incredible creatures provide the blueprint for how to survive under that kind of mind-bending pressure. And that just leaves us with this truly profound thought. Life has already figured out a way to thrive under an absolutely astonishing, crushing force right here at home. That fact alone forces us to completely expand our imagination about what's possible. The boundaries for where life can exist are so much wider than we ever thought, which leads to the ultimate question: where else is it hiding?